Okay, so I would do two different videos for you today. The first of those is going to be a liter to mole conversion and mole to liter conversion video. We'll talk about that, but first I want to get into some of the reasons why we use liters. In the past, we've talked about moles of something, and certainly we can, kind of think about how many atoms or how many molecules there are, just the number of them if we counted them out. We could also a lot of times think about the mass of that, and there's a relationship that we can find between mass and moles. However, gases don't really obey, or they're not very well behaved when we try to measure the mass of these things. So gases are not easy to put on a scale. We can't really just, calculate the mass of these things. So instead, what we like to do is think about the volume that they occupy. Here, if we have some gas at standard temperature and pressure, which is STP, so STP for standard temperature and pressure, if we have some gas at standard temperature and pressure, then all gases will occupy the same amount of space, and that is 22.4 liters. All gases, if you have 1 mole of them, will occupy that 22.4 liter space. So in one way I could say it is if I have 22.4 liters of a gas at STP, I will have 1 mole of it. Or I could say that if I have 1 mole of a gas at STP, I will have it occupying 22.4 liters of volume. Now, this is a pretty important thing, but it's also fairly easy to calculate the the conversion between a liter and a mole. So let's go ahead and get started with this liter to mole conversion stuff. First of all, I have a question that says how many moles is 16.9 liters of helium gas? So I write out my 16.9 liters, and that means we are on volume island. And if we want to go to mole island from volume island, we have to set up our boat, right? In our boat on the bottom, we like to put our liter stuff because that goes down storage. We don't need it anymore because we are headed from liter island to mole island, and we will need our mole stuff up on top. I'm putting the 22.4 liters down below in storage. I'm putting my 1 mole up above in the top deck. So I do this division, and the answer I get is 0.75 moles. So if I have this 16.9 liters of helium gas at STP, I will have 0.75 moles of that gas. I also have, let's say, 22.0 liters of neon gas, so 22.0 liters. That means we are on liter island and we want to go to mole island. And so to make that trip, we would put our liter stuff below deck. That is our 22.4 liters. And above deck, where we want, where we want our stuff, will be our moles, and that was 1 mole. By 22.4, if I take 22.0 divided by 22.4, my liters cancel with the top and bottom. And the answer I get is 0.98 moles. Now, the next question looks a little bit different. You see, we're transitioning between a liter of gas and of neon, spelled out NEON, and this H2 gas stuff. And there's two types of gases that we typically deal with in this class, and those are the noble gases, which you might recall from an earlier class, and our our diatomic gases. So noble gases are, the neon, bromine, or sorry, neon, krypton, stuff like that, and they are pretty easy to pick out because they occupy this leftmost column on the periodic table: helium, neon, argon, krypton, xenon, and radon. These are all gases. At STP, they will obey this 22.4 liters per mole thing, but there's only one of them in a molecule. And so if you have if you have a certain number of liters of it, you can convert it to moles. And then when you go to convert, say, from moles to formula units, you will know how many atoms you have because there's only one helium atom in a helium gas molecule. There's only one neon atom in a neon gas molecule. However, these other gases, and you can see them, they're over here. We have a hydrogen, we have fluorine, oxygen, nitrogen, hydrogen. All of these with the red letters, they will be gases. And they will be gases as a diatomic gas. with di meaning two and atomic meaning atoms. So these are two atom gases. It means that there's going to be two hydrogens in a hydrogen gas. There will be two nitrogens in a nitrogen gas, two oxygens in oxygen gas, and so forth. So all of these gases are going to have two atoms. And so when we go to convert between our from liters to atoms, we have to do liters to moles, moles to formula units, and then formula units all the way to atoms. So just be careful about that. When you look and you see a formula like H2 instead of a word like neon, you might have to do an extra step if it's a multi-step problem. And we'll cover that here in the next video. So let's get back to the task at hand, and that is to convert 3.9 liters of H2 gas into some number of moles. So I write out, let's change color because this is a different type of problem, 3.9 liters of H2 gas, and then I draw my boat. And below deck, I am storing my liter stuff, right? We have the number of liters, so we're on Liter Island. I store my 22.4 liters below deck. Above deck, I put my 1 mole. When I do this thing, or when I plug this into my calculator, I get something like 0.17 moles. We have another question here. It looks similar, but maybe a little bit different worded, because we could give our volumes as liters, L-I-T-R. We could give it as 1 L. We could give it as other ways, but I just wanted to show you a couple different ways that you could get this whole liter thing. So we have 1 liter, and it is at STP. Assume for our video purposes, every one of these is at STP. But in your progress checks and in your summatives, you'll be told specifically that we are at STP. 1 liter of nitrogen gas at STP will occupy 22.4 liters. And on the top here, we will put our 1 mole, because it's 1 mole per 22.4 liters. My liters units cancel, and then when I do this division, I get 0.04 moles. So there will be 0.04 moles of N2 gas in 1 liter of that N2 gas. Okay, moving on to the next part, the next page, here we are. So how many moles is 9.88 liters of C3H8O? And this is an interesting molecule. Doesn't really do anything fancy, but I like to say its name, and that's methyl ethyl ether. A little bit of a tongue twister. So we have 9.88 liters of this, and we don't need to write out the molar mass. We don't need to find the masses of carbon, hydrogen, oxygen. All we need to know is that this is a gas at STP. It will occupy 22.4 liters for every 1 mole. Or 1 mole of this gas will occupy 22.4 liters. So if I have that 9.88 liters, and I multiply it by, I put my boat there, we are on volume island right now, so we are going to mole island, which means that our volume stuff, or our liters, goes below deck into storage, and above deck we put our 1 mole. When I do this math in my calculator, I get 0.44 moles. 0.44 moles of this methyl ethyl ether will have 9.88 liters of space at standard temperature and pressure. Okay, now we have a slightly different type of question. We are given the number of moles, which means we are on mole island, and we need to get the number of liters, which means we are headed to volume island. This means that our boat is going to flip over, and then we're going to put the 22.4 liters on top and our 1 mole down in the bottom. So I start off by writing my number of moles that I have, 13.7 moles. I write my boat, and below deck goes my mole stuff, which is 1 mole. And above deck goes my liter stuff, 22.4 liters. So I take those two numbers, the 13.7 moles and 22.4 liters, I multiply them together. Our units of moles above cancels units of moles below. And my answer is 306.88 liters. So this 13.7 moles of xenon gas will take up a total volume of 306.88 liters. Then we have how many liters will 2.74 moles of F2 gas occupy? That's that fluorine diatomic gas. And to figure this one out, we just do what we're doing before. 2.74 of our moles. We are on Mole Island, and we want to go to Liter Island. So we put 1 mole down below, and above we put the 22.4 liters. I get 61.38 liters of gas. So my 2.74 moles of gas will occupy 61.38 liters of volume at STP. Next question is, how many liters of volume will 6.38 gas or molecules, sorry, how many liters of volume will 6.38 moles of oxygen gas occupy, or O2 gas? So we take our number of moles and we write it out, 6.38 moles. I keep forgetting to cancel my units. We need to cancel units. So 6.38 moles. I draw my boat, and the below deck is the 1 mole from Mole Island, because we are going from Mole Island to Volume Island. And on top, I put my 22.4 liters. When I do this multiplication, I get 142.91 liters. So this 6.38 moles of my O2 gas will occupy a total volume of 142.91 liters. So hopefully this has helped you see the process a little bit. Again, this one is one of the ones I think is kind of, I thought it was the easiest one when I was learning this, because everything's 22.4 liters. Everything's 22.4 liters. We don't have to calculate the molar mass when we do just a one-step conversion problem. It's really nice, so it's fairly easy for us. The last problem, just to kind of drive it home, let's talk about 1.2 moles of C6H6 gas, and how many liters will it occupy? This is benzene. I talked about that in an earlier video. Super important for industrial chemistry. But we start off by writing out our 1.2 moles. And to that, I multiply my boat, which I store my mole stuff below because we are leaving Mole Island. We don't need it anymore. So my 1 moles goes below, and my 22.4 liters goes above. So all I have to do is plug this number into a calculator, that 1.2 times 22.4, and I get a total of 26.88. So 26.88 liters is 1.2 moles of C6H6 gas. In fact, 26.88 liters is 1.2 moles of any gas at STP. Doesn't matter what's here, we can convert between liters and moles. Things get a little bit more difficult when we start to leave Mole Island and go to places like Mass Island or Formula Unit Island. If we do that, then we can't just, assume everything is the same. But here, when we're going from liters to moles, it's very nice because everything is 22.4 liters per mole. All right, that's about all I have for these questions. Hopefully this helps you out, and hopefully you'll do well in the summative on this stuff. So good luck to you, and we'll see you soon.